Okay, illustrative math, Algebra 2, Unit 4, Lesson 9 is called What is a Logarithm? So our goal today is I understand that a logarithm is a way to represent an exponent in an exponential equation. So as you look at this, you might say, well, wait, hold on. What is an exponential equation? So an exponential equation is an equation with the variable as an exponent. So when I look here, this is an exponential equation on the left because I have x in an exponent. A lot of people look at this one on the right and they think that this is exponential because there's an exponent. But 3 to the second, remember, you can simplify this. This is really going to be 2x plus 9 equals y. So then when you get it here, it's actually in the linear form, y equals mx plus b. So this here is actually a linear function or a linear equation. And this one here is exponential. So it's important to make sure you understand that exponential equation does not mean simply that there is an exponent in the equation. It means that your variable is in the exponent. All right, find the estimate to each value mentally. So this one easy. And again, these are exponential equations because your variable is an exponent. So this one's really easy. You'd say a to the second would give you 16. B to the what equals 2. It's going to have to be square root of 4 to get 2. So it's going to be 1/2 because remember, 1/2 power is the same as square root. Okay, so this one here is not an exponential equation because you don't have the variable in the exponent. So again, fraction exponent here, remember the bottom number is the root, the top number is the power. So it's going to be square root of 4 to the 5th. So the square root of 4 is 2. 2 to the 5th is 32. All right, and then here's where you start getting into some problems. You get 4 to the d equals 56. And you start saying, okay, well, 4 squared is 16, so it's not 2. And then you get here, you say 4 cubed. Well, that's 64. So, what would I do? So it's going to have to be some sort of decimal here. Um, so, right at this point, you're just kind of taking a wild guess here. You're going to say, d equals 2.8 because I'm saying 56 is closer to 64 than 16. But then, I'm going to check it. I'm going to take my calculator. I'm going to say 4 to the 2.8. And it's actually kind of way off. So my estimate wasn't very good. 4 to the 2.8 equals 48.502. And I actually rounded it. So I probably shouldn't even use the equal sign. I should probably use the approximation sign because this is rounded. So I don't know. Maybe I'm gonna try 2.9 here and see what happens there. So I type it in 4 to the 2.9, and I'm getting pretty close there. I'm getting 55.715. But again, it's still rounded and it's still not exact, but that's about as close as we can get right now. But we will learn how to do a little bit better, a little bit more accurate method with these logarithms here eventually. Okay, so find the value of y that makes each equation true. Okay, so 10 to what power y equals 1? That's going to be 0. Anything to the 0 power equals 1. Obviously, this would be 10 to the first would give you 10, so y equals 1. Let's see, this one would be y equals 4. Okay, take your calculator here. 10 to the 4th equals 10,000. And then this one would be y equals, I think, 8. Okay, because I think 10 to the 8th. You can check it on your calculator, 10 to the 8th. Sure enough, it gives me 100 million. Yep. So it would be working. Okay, and I could write all those out. But now here it gets a little bit harder because, okay, so it's not 1 because if I plugged in 1, 10's not equal to 9. So it's got to be a little bit less than 1. So like here's where I'm going to kind of estimate. I'm going to say 0.9. Okay. Now, if you want to get more accurate, you could say you could start using your calculator and kind of trial and erroring it. So I'm going to do 10 to the 0.9. I'm actually kind of off with that. If I say 10 to the 0.9, it gives me 7.943. I want it to equal 9, so I probably maybe need to make it a little bit bigger than 9. So here's where I'm going to change it. I'm going to make it like 0.95 and see where that takes me. So 10 to the 0.95. Now I'm getting pretty close. I'm getting here at 8.91. So I need to get a little bigger. So, if I wanted to make it 0.96 or 0.955, something like that, I could. But I'm going to chop it off right there. Okay, so here's where, we know that it's less than 2 because 10 squared is not equal to 90 because it's 100. 100 is not equal to 90. So it's got to be less than 2 to get a number closer to 90. So, because 2 will give me 100, that's too much. So I got to, I'm going to again start trial and erroring it here. Let's try like 1.9. 10 to the 1.9, and I see what that gives me. And I get 79.432. Not big enough. I want it to be 90, so I got to make it bigger. I'm going to try 6. I don't know. 1.96. 10 to the 1.96. And that got me pretty close. That got me to 91.201. Okay, so that's pretty close to 90. Still not equal though, right? 91.201. It's still not equal, but it's a pretty good estimate. Okay, so all right, so here's some tables here. And we have the X column, and you can think of this as the Y column. Think of it as Y equals log base 10 of X, okay? So this first question here, and I don't know how this textbook thinks that you're going to be able to answer this question. Says analyze the table and discuss with the partner what you think the table tells us. I don't know if I don't know. I don't know if anybody's gonna be able to find that, but you might be able to. If you want to pause the video and try to see what the tables tell us, then you can. But I already have the answer here. I'm gonna give it to you. So the column on the right, Y, is the exponent that you would raise 10 to so that you get the value of the column on the left, which is X. So let's start with a whole number. Okay, so let's pick this one here. Okay. So you're going to say, since this base here is 10, okay, right here, since this is 10, it's basically telling us, okay, 10 to what power y gives us x. Okay, so in this column, you're gonna say 10 to the y, because this is your y column. 10 to the second gives us the x value of 100. Okay, so and that works. And then let's try another one here. Maybe let's go to another whole number one right here. So you're going to say, okay, 10 to the third power equals 1,000. And you see that it works. It checks out. So maybe like try a decimal here. So maybe like let's do this one, see if it works. And I'll come up here. So you're going to say 10 to the 3.8451. See if that gives us 7,000. So you're going to check it out on your calculator. 10 to the 3.8451. And sure enough, it gives me 7,000. Now it's actually a little bit, it's not exact. It's actually 7,000.03. 3, and it keeps on going, but pretty close. All right, so that's what these tables tell us. All right, so this is going to be helpful now. Some of these you could do kind of with mental math, like for this one here, 10 to the W equals 1,000. You can kind of say, oh, well, 10 to the third would give me 1,000. But here you can't figure out, the power is going to be going to be less than 1 because 10 to the first is 9. So what I'm going to do is I'm going to go to my table here, and I'm going to find the one that I'm looking for, which would be right here. So I'm going to say, all right, 10 to the 0.9542 should give me 9. Okay, so I can say y equals 0.9542. And then here for this one, we're looking for 90. So that would be right there. So I'm going to say z equals 1.9542. Okay, so that's basically what you would take 10 to get 90. All right, notice that some values in the columns labeled log base 10 of x are whole numbers, but most are decimals. Why do you think that is? So the reason is because if you take 10 to whole number powers, there's only so many numbers you can get, like 10 to the 0 would be 1. 10 to the first is 10. 10 to the second is 100. 10 to the third is 1,000. So there are a lot of numbers between 100 and 1,000. So that would mean that you need to raise 10 to a power between 2 and 3 to get any value from 100 to 1,000. And obviously the only numbers between 2 and 3 are whole numbers, okay? So, if I have, 10 to what power equals, 600. Well, if this number is not 100 or 1,000, then obviously that's between those two values. Your exponent's going to have to be between 2 and 3 as well, okay? So that's why you'd have to get a decimal, because that's the only numbers between 2 and 3 are not whole numbers, decimals, fractions, irrationals, things like that. All right, so what is a logarithm? Because that was our goal, let me go back. Our goal was, I understand that a logarithm is a way to represent an exponent in an exponential equation. So here's the definition. You're going to want to write this down somewhere. If I have b to the x equals y, I can rewrite it in log form as log base b of y equals x. So you're just moving the pieces around, okay? So 3 to the fourth equals 81. That is going to be log base 3. Do you see how your b is as your base here, and b is your subscript right there? Log base 3 of 81 equals 4, okay? Now, if I want to go backwards, this is my base, this is my exponent. I'm following this definition here. So I'd say 4 to the second equals 16. Over here, this would be log base 6 of 1/36 equals -2. This would be 2 to the fifth equals 32. And this would be log base 9 of 3 equals 1/2. Okay? Oh, one more. So this would be 6 to the third power equals 216. Okay? All right. So here's two equations based on the information from the table. What values could the question mark in these equations could replace the question mark to make these true? So we just learned log base b of x equals y. That's log form is going to be b to the y equals x. Okay. No, I used it back. I wrote the letters backward. I want to stay consistent. I guess it doesn't matter, but I want to use the same letters. So log base b of y equals x would be b to the x equals y. So this is going to be 10 to the question mark equals 1 million. So you got to think 10 to what power equals 1 million, and the answer is going to be 6. And you can check it on your calculator. 10 to what power equals 1. So I'm using these definitions here. My base is 10. So my base is 10. I switch the b right there. Question mark goes up in the power because that's what it's equal to. That's where the x was. And then the y is the 1 right there. So obviously that's going to be 0. 10 to the 0 would give me 1. And 10 to what power equals 4. So I might need to go back to my table and look right here at this row, 10 to the 0.6021. 6021, is that what it was? 6021, yep. All right. Between which two whole numbers is the value log base 10 of 600? Be prepared to explain how you know. Well, 10 to the first is 10. 10 to the second is 100. 10 cubed is 1,000. So it's obviously, since 600 is between 100 and 1,000, it's going to be between 2 and 3. Okay. The term log is short for logarithm. Discuss the following questions with a partner and record your responses. What do you think logarithm means or does? So a logarithm rearranges an exponential equation so that it is solved for the exponent. Okay, so like when I say that here, if I have like, I don't know, let's go back to that very first one that I had. Let me go back. I said 3 to the x equals y right here. So 3 to the x equals y. So right now it's solved for y. What if I said solve for x? I want to rearrange it so it's x equals. Well, the only way to do that is to change it to log form. So I could just say log base 3 of y equals x. Now it's solved for x. Now it's x equals, okay? So actually, if you took this equation and typed it in on a graphing calculator, and then you typed this equation in on a graphing calculator, like on maybe Desmos, you'd get the exact same graph because they're the same equation. They're just rearranged, okay? So that is y, okay? All right, next to log is a subscript, a number or letter printed smaller and below line of text. What do you think the subscript tells us? Okay, that tells us the base that you're going to raise to a power. All right, what about the other two numbers on either side of the equal sign? For example, the 100 and the 2. Okay, so the 2, so let's say the 100, let's say the number on the right, the number that the logarithm is equal to is the exponent the value next to the logarithm is the value that the base raised to the power is equal to. Okay. All right, so we saw the equations such as log base 10 of 100,000 equals 5 today. In that equation, what does the 10, 100,000, and 5 tell us? So obviously the 10, this is my base. This is my exponent or my power. And this is the value that the base raised to the power equals. Okay. How do we read an equation such as log base 10 of 100,000 equals 5? I'll write it down so you got it. We would say log base 5 of 100,000 equals 5. How would you describe the meaning of logarithm to someone who has not heard of it? I would say we are rearranging an exponential equation or function so that it is solved for the exponent. I would say there are 3 parts of a logarithm. The base, the exponent, and the value that the base raised to the exponent equals. And I would say that you need to know this definition here. I need to say b to the x equals y would be log base b of y equals x. So here it's solved for y, here it's solved for x. These are the exact same thing. They're just in different forms. Again, if I were to graph a log function and an exponential function, as long as my pieces are switched in the right spots, I'd get the same graph. All right, what values could the question mark in these could replace the question mark? So 10 to what power? So this is my base, this 10. This is my question mark's my exponent. 10 to what power equals 10? Well, that would be 1. 10 to the first would be 10. This is my base, 10. This is my exponent. To what power equals 10,000? So that would be 10 to the fourth. 10 to what power gives me 7. I'm going to have to trial and error it, or you could go back to your table. I'm going to flip back to my table. 10 to what power equals 7, and that's right here, so 0.8451. 0.8451. Okay, you could trial and error it, or you could go to the table. How would you explain to a friend who doesn't know about logarithms what the equation, I don't know what that was supposed to say, I got cut off, what the equation, let me check here if I got that in my book here, what the equation, I don't have it. So I'll just skip that one. All right. So there we go. Hope you enjoyed watching this video, and we'll see you next time.